We are looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. In this video, we are going to see how we can decode the transpose, coding that we have done. Now, remember the transpose coding. The idea was that, basically we take every, for example, fifth letter in this and lump it all together. So, for example, 0, 5, 10, 1, 6, 11, and so on and so forth. Now, what happens here is quite interesting. Unlike the other, encoding here, all the characters get mixed up all across the screen, and hence it's quite interesting. Now let's think of decoding this. In fact, the picture here gives a hint. All we really have to do is to lump, once we have done this decoding, now we notice that each of these substring is of length 3. That's because totally there were 15 elements and we took every fifth of them. So each of these ends up with 3. And as you can see very clearly, if I could lump every third character now, then I'll be done. So, I'll basically go P, Y, T, H, O, N, and so on and so forth, and I'll get this string. So basically the idea is that if I look at, the same algorithm being run on this, but not 5, but rather third character being picked up, I'll have decoded this. Let's look at one more example. Let's say it was n was 4. Now in this case, my total length is 16, in which case my every substring is of length 4, and all I really need to do is to just look at the fourth character once again. Now in this case, it turns out that my encoding was with 4, decoding is also with 4, but that's just because the length of the string is 16. If the length was 20, then I would have to look at every fifth character. The general rule that comes out here is that, recall that we end up with n substrings. So we are, the index is n. Each of these substrings has the length of n by message. That's what. In order to recover the original message, we just need to lump every length message by nth character together. In other words, and this is so interesting, we just need to run the same exact transpose code once again, but with n replaced with length message by n. And this is so powerful. Let's look at some examples. Recall previously I'm doing n equals to 6 and I've transposed this x of t. Let's run this again. So, my x is, of course, meet me in the lobby at 6 p.m. X of t is, say, something else which has been transposed with n of 6. I look at the length of xt and that is 30. So all I need to do really is to say, okay, look, let me just transpose xt with 30 divided by 6, which is 5. And if I do that, I get the exact message that I was looking for, which is meet me in the lobby at 6 p.m. We can take one more example. Let's say my n was equal to 4. Now in this case, so let's say my x of t is something else. I look at my length of x of t, it is 28, which means that I have to now transpose this. If I transpose, let's say, x of t with 28 divided by 4, which is 7, I expect to get the correct message, which is meet me in the lobby. It's quite amazing. It's like a lock opening the key. Just for, sake of completion, let's say I did not follow this rule. I sort of, decoded this with some other, let's say, key. I will end up with something else because that's not the right key. So basically the point is that if we are doing this, then the recipient of this message should also know what n we have used, so that he or she can then apply the the length by n to decode this message. We can make this a part of the code. So like I said here, I can say xt, for example, say let's say xt, say decode, and I'm going to just transpose this once again and say call it xt len of, let's say, xt over n. Now this may return me a float, so I'll just convert this to an integer, just to int of this, and really that's all I need. Have I got it all correct? So I need one more bracket over here. Yeah. So with this, if I run this code now, for example, I see x of t is this, xt, for example, decode is meet me in the lobby at 6 p.m. See how beautifully this thing works and how we are able to use the same code for, decoding and encoding with just different values. Now, before I wrap this up, I just want to tell you something very, very interesting, which will also kind of answer why is it that we call this transpose. Now, the viewpoint here is very beautiful. Let's start with n equals to 5. Notice I'm grouping this by every fifth character, which is kind of same as saying that, okay, I have a grid of 5 times 3, which is 15 characters. I write this message into the, into this grid in a row by row fashion. So I kind of write like Python, then whatever n dash I thing, and then I read this column by column, and that will have the same effect as encoding this. Now, since I'm using the same algorithm for decoding, it's like saying, okay, I'm going to write this whole thing in a row by row fashion. This time around three rows, sorry, three columns, because remember this is three. So I'm basically writing three columns here, five rows, and I just read this in a column by column. Yeah, so I write row by row, I read column by column from top to bottom. So I get the message that I was looking for. Now this kind of like, this is the interchange between row and column, and that's why I called this transpose. In fact, we can see the same thing with the four. So again, I write it row by row, and then I read it from top to bottom, column by column. And this is a very powerful viewpoint, very interesting. The same thing happens on the decode. I hope you found this interesting. In general, if you relate to this method of learning, if you find that this is fun, it's fun to do activities, look at our website, because we have many, many, many such activities. Take care. Thank you so much. Enjoy Python.